now we will be dealing with the decision tree regressor. So the I'll explain classification as well as regression at one time. Okay, you don't get confused between regression and classification. The back-end phenomena, everything will be similar in decision tree regression as well as the classification. All right, guys. So now I'll start with this decision tree regressor. Okay. So can you please tell me what do you understand by decision tree and regressor? What is regressor first? What do you understand by regressor? Regressor means predicting. What is classification? Classification also prediction. So regression is nothing but the statistical relation between inputs and outputs. So how can you say that is a regression kind of algorithm? How can you say that is a regression kind of algorithm? So whenever you have a numerical output, then you consider that as a regression algorithm. All right. Now, decision tree means decision tree. Tree means it's like a tree structure. Yes or no? So this decision tree regressor is applied to the data which is in the form of a numerical value based on creating some sort of decision trees. Creating some sort of decision trees. So based on those decision trees, your decision tree regressor will be created. All right, guys. So let's see how that happens. Before that, I would like to just give a small example. All right. I want to give a small example. So here I want to take a classification problem. I'll explain the decision tree classification, and then the same phenomena will also be applied to the regression problem also. All right. So here I want to check whether we can give loan to a person or not. Okay. So whether we can give loan to a person or not. So in order to predict this, we have some columns like balance he is maintaining. Balance he is maintaining. Okay. Credit card score. Does he have loan? What is the amount of loan he has? Etc. Let's suppose these are the columns that are there in the data set. Okay. The output column is you can grant it or not. So based on these columns, the decision tree will be creating a tree like structure. So first what it will take is, the decision tree will consider balance. So here a tree is formed. So greater than 50,000, less than, greater than 50,000, less than 50,000. So if suppose balance is greater than 50,000, then check the credit card score. Credit score greater than 800, less than 800. Fine. If he is having, or else like if it is greater than 5,000, he can also check loan greater than 8 lakhs, less than 8 lakhs. Then after that he will check credit card score greater than 700, less than 700. So here I'll have some data like this. Okay, so balance he's maintaining is like 60,000. Credit card score he has is 888. The balance he is having is, or else the what is the loan amount is, suppose 9 lakhs. Then you may grant the loan. Okay, so now how our decision tree will take is, first of all it decides on the balance. So first it checks what is the balance is greater than 5,000 or less than 5,000. Fine. First it will check this node. It is greater than 50,000. I'm sorry, greater than 50,000. So as soon as it is greater than 50,000, immediately it is checking the loan. Immediately it is checking the loan. If loan is 8 lakhs, greater than 8 lakhs or less than greater than 8 lakhs, then it will check the credit card score. If it is greater than 700, then it says yes, you can grant. If it is less than 700, no, you cannot grant. No, you cannot. So here if it is less than 500, it is no only. No, that is not granted. No. If it is less than 8 lakhs, I'm just giving some sort of decision tree, that's it. This also no. Okay, now I will give some data like this. 70,000, he is having the balance. He has having 600 as debit card score, I mean the credit card score, and 5 lakhs as the loan. Now, a person data is in this way. Now, from this tree, you people tell me whether this person will get loan or not. You people tell me whether this person will get loan or not. First, it will check the balance. So the balance is greater than 50,000. Yes, it is greater than 50,000. Now it checks the loan. If suppose if it is less than 5 lakhs, then it is properly a no. Right? So can you see this? This is a form of decision tree. Can you consider this is a form of decision tree? Yes. So however, we have taken few of the things and are deciding it whether he can get loan or not. The same phenomena will be there in the decision tree also. So here I randomly took the values, but why only balance should be taken? Why only these values should be taken? How can you consider if it is less than 5,000 it is no, if it is greater than 5,000 it is yes? That will be taken care by some sort of mathematical equations. So now let's see what will happen in the decision tree. All right, guys. So did you understand this, everyone? Did you understand till here? Good. So now let's move on to the decision tree, actual mathematical implementation of the decision tree regressor. Decision tree algorithm is one of the most used algorithms which is used for classification as well as regression. Both classification as well as regressions. And for this decision trees can be considered as the predictive models that uses a set of binary rules to calculate the target value. So target value is nothing but the output. Okay, so in order to calculate the output, it will set some of the binary rules. So these rules are categorized with the help of a tree. So each individual tree is a simple model that has branches, nodes, as well as leaves. Okay. So here, this is called as root node. These are called as branches. These are called as leaves. Yes or no are considered as the end nodes. So you'll get to know what are all these things within few minutes. All right, guys. So in decision tree, I already told you it is used for regression or classification in the form of a tree structure. It breaks down the data set into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. So first the data set is split into subsets: balance, loan, credit card, subsets, and each has some sort of decision nodes, right? So this can be observed with the example that I have discussed. And then the final result is a tree with decision node and leaf node. So decision node is nothing but the decision node which is used to predict the output. All right, guys. So now let's get into the theoretical explanation of the data. So first, suppose this is the data set that I have. Okay, so here I have 4 data. One is 4 columns, one is 5 columns, one is day, outlook, humid, wind, and play. So this data set tells about a boy who gonna play or not play based on the weather conditions. So on day 1, the outlook was sunny. It was very humid, high humidity. Wind was very weak, so he didn't play anything. On the next day, it was sunny. Humidity was very high. Wind is very strong, even though he didn't play. The next day, overcast. So these are the data which is there in the data set, which will say whether the boy will play or not. So now from this, can you please tell me how many yeses are there and how many no's are there? How many yeses are there and how many no's are there? Fine. So put it in the mind. Here I have out of 14 observations, I have 9 yeses and 5 no's. These are the training examples. All right. Just put that in the mind. Now, what happens? A 15th day observation came. It is rainy, humidity is high, wind is weak. Whether he will play or not, I don't know. First of all, you have to break the data set into simpler data sets and then check. So now our machine learning algorithm should predict whether this person will play or not based on these inputs. Now what I do is, I will split the data set with the help of the outlook column. So in outlook column, how many categories are there? In outlook column, how many categories are there, guys? What are they? Sunny, overcast, and rainy. Yes. So now what I am doing is, I am splitting the data into simpler set. The first one is outlook. Here it is overcast, sunny, and rain. All right. Now, in sunny, how many observations are there? In overcast, how many observations are there? And in rainy, how many observations are there? In sunny, how many observations are there? Out of 14. In overcast, how many observations are there? In rainy, how many observations are there? For overcast, I have 1, 2, 3, 4, 4 overcast, 5 sunny, and 5 rainy. Yes or no? So now, what I do is, I will take those observations. Now, what I did, I split the data into some data sets. So this splitting will be done until the split becomes a pure set. Pure set is nothing but it either has all yes values and all no values. A pure set is considered, a set is considered as pure if suppose that set has all yes observations or all no observations. So here, what is the pure set and what is the unpure set? Here, what is the pure set and what is the unpure set? Overcast is pure. Overcast is pure. Sunny and rainy are unpure because the overcast has all the yes values. Now, this sunny will be splitting into other subsets. So here first the data Outlook got splitted. Over here it gets splitted on wind. It gets splitted on wind. So here wind or humidity. Okay. So now in the next step it is called as pure set. This is an impure set, so that's the reason you have to split it further. This is also an impure set. That's the reason you have to split it further. Now, after that, then it is splitting in the humidity. Splitting in humidity. So, here humidity is high or normal. Yes or no? Again, it has so if you take humidity, what are the observations you can find? If you take humidity, the humidity, two categories, which is high and normal. And from that also you can get the observations, right? Likewise, we got in the overcast. Here also, I got in this way. So sunny, high, weak, sunny, high, strong, sunny, high, weak. Now this is normal and normal. Now again in the weak. Again weak has, again in the wind has weak as well as strong. So weak data is considered and strong data is considered. Now can you consider all these as the Can we consider as these the pure sets, guys? Can you consider these as the pure set? Everything is pure set only, guys. A set is considered as pure if it has all no's and all yeses. All right? Yes. Now my decision tree is formed. Now let's look into the data that is given before. So it is a rainy season, it is a high wind, it is a high humidity, and it is a weak wind. Now based on decision tree, just tell whether the person will play or not. It is rainy, high humidity, wind is weak, whether he will play or not. He will play. Why? Let's see. It is rainy. So in the rainy spirit, humidity is not there. So no need of considering the humidity. So it has to consider the wind. Wind is strong. Wind is weak. So that's the reason he will play on the particular day. All right. So this is how a decision tree is formed based on the classification problem, based on the classified data. Did you understand till here, guys? A data set is splitted into different subsets. Those subsets should be pure subsets. Until and unless the subsets are pure, the decision tree will not split the data further. Right? So did you understand till here? Yes? Cool. Now, why am I supposed to put this only on Outlook? Why can't I split the data on wind or humidity or something else? This will be decided by some of the mathematical formulae which are called as entropy and information gain. So did you ever heard about the entropy? So now which attribute to be split on, whether is it outlook, whether is it wind, or whether is it humidity? That is purely based on entropy. So can you please tell me what do you know by entropy? Do you know what entropy is? Did you ever heard about this entropy? In physics, you didn't heard about this entropy? Entropy is nothing but called as disorderedness of the data. Disorderedness of the data. That means entropy is used to calculate the homogeneity of the samples. Entropy is called as disorderedness of the data, and it is used to calculate the homogeneity of a sample. If the sample is completely homogeneous, the entropy will be zero. If the entropy is zero, then the sample is equally divided. For suppose, if I give, so I should again explain you what entropy is. So that's the reason I'm just taking a small example. So for suppose, if you want to, I have given you a box of toys, books, crafts, etc. Okay, fine. Now I want you guys to separate those data into different things. So at that time, what you do, you make another carton with toys, you make another carton with crafts, and you make another, and the carton will be there with the some books, right? So here all those things are in a single box. So that means the disorderedness of the data is high. The data is not very clean, or it's not properly ordered. Now whenever you split that into different things, then that becomes the homogeneous data. That means all the things have come into a proper format. So in order to split this, you have to find the entropy. If suppose entropy is zero, that means everything is properly managed. If suppose entropy is high, that means it is the combination of all the different data. So did you understand what entropy is now? Did you relate it with the example that I've explained? Entropy is nothing but disorderedness of data, guys. So in order to uh, properly arrange all those things, then we need an entropy and the information gain. So how do you calculate the entropy? So the calculation of entropy is nothing but with a formula minus P plus log 2 P plus minus P log 2P. So what is this? We will see. S is nothing but the sample of training examples. P plus is the proportion of positive examples in S. So what is the proportion of positive examples in S? Positive examples means yes. What is the proportion of positive examples? In the data set that I've given you, what is the proportion of positive examples? So in the data set, yes, 9 are positive and 5 are negative. So based on this formula, you will get the entropy value. So let's calculate the entropy value first. So minus P. Minus P is nothing but the probability. So 9 divided by 14. I hope everyone know the probability, right? So entropy is calculated by probability of yes is log 2 to probability of yes minus probability of no into log 2 probability of no. So the probability of yes will be 9 by 14 log 2 9 by 14 minus 5 by 14 log 2 5 by 14. So now you get a formula which is 0.939. So that means entropy is high. So if the entropy is high, then the randomness or the disorderedness of the data is high. So that's the reason you have to split the data into separate parts to get the pure set. So how do you make the outlook as the one that is purely based on the information gain? So information gain will reduce the value of the entropy, will reduce the value of the entropy. So the information gain is also expected the reduction in the entropy caused by the partitioning the examples with respect to an attribute. So the formula of the information gain is total entropy minus, I'll say what is this, SV by S, and entropy by SV. SV is nothing but the entropy of a subset. So here how many subsets we have? We have outlook as a subset, we have wind as a subset, and we have, humidity as a subset, and we have wind as a subset. So first of all, you have to calculate the entropy of outlook, entropy of wind, entropy of humidity. So first we will calculate the entropy of the wind. So in the first example, just take wind only. In the first training example, just take wind. So in wind, how many S's are there and how many No's are there? Just consider wind only, guys. In wind, how many S's are there and how many No's are there? In wind also, 9 yeses, 5 no's. In wind, I want to consider weak as well as strong. I want to consider weak as well as strong. So if you consider that, then you will get in wind, you have 9 S's and 5 no's, out of which you have weak as well as strong. For weak, you will have 6 S's and 2 no's. Yes? For weak, you will have 6 yeses and 2 no's. For strong, you will have 3 yeses and 3 no's. 3 yeses and 3 no's. Now let's calculate the entropy of weak. So what is the entropy of week? Total number is 8. Total number is 6. 6 plus 2, 8. So 6s is divided by 8 log 2. 6s is divided by 8. Now 2 no's divided by 8 log 2. 2 no's divided by 8. This is the entropy of weak. I'll tell you what is this 8 by 14 within few minutes. This is the entropy of weak. This is the entropy of strong. Now, what is this? Total number of observations in the week divided by total number of observations in the training data set. So in the week, the total number of observations are 8. So that's the reason 8 divided by total number of observations in the data set is 14. So SV by S is nothing but SV is nothing but total number of samples in the split, and S is nothing but the total number of samples in the training set. So 8 by 14 into entropy of weak. Here in the strong you have 6. So 6 by 14 into entropy of strong. Now you got a value something like this. Now add them. And you also have the information gain formula as entropy minus sum of entropies of splits. So now you get 0.939 minus 0.463 plus 0.428. So you get 0.048. So you got information gain as 0.048. Now let's do that on the outlook also. So in the outlook, again you have sunny, overcast and rain. So in sunny, you have observations as 5, out of which 2 are yeses and 3 are nos. Even overcast, you have 4. All those 4 as yeses only. In that rainy, you have again 5 observations, out of which 3 are yeses and 2 are nos. So you will be calculating the entropies of all the sunny, overcast and rain and calculate the information gain. Again, information gain is nothing but entropy minus sum of entropies of the splits. So you got 0.247. So based on this value, you have to consider whether the root node is outlook or wind or humidity. If suppose the value of outlook is 0.247 and the value of wind is 0.048. So which is bigger? 0.048 is bigger. So outlook is considered as the root node. So whosever value of information gain is high, that is considered as the split. So now outlook is considered as the split. So that's the reason first we have splitted the data on outlook. Once that is done, then again you have to again calculate the entropy for high and normal. Again, you have to check whether that is humidity or wind. Again, you have to calculate the entropy and information gain for wind. Then you have to split the data into subsets based on the information gain and entropy. So did you understand this, guys? So what is the formula of entropy? Did you understand this, guys, everyone? So what do you mean by entropy? What is information gain? What is the information gain? Yes, good, guys. So this is how our decision tree regressor will work. Now, random forest is nothing but the different decision trees. So data set is divided into different decision trees. So each data set is divided into different data sets. So for each data set, a decision tree is found. So based on the data set, the mean value is considered as the output. So in the decision tree, the whole data set is given once, but in the random forest, that data set is divided into different splits. Then for different split data set, a decision tree is applied. So the answers of all those three are considered, the mean of answers for all those three are considered for the answer. Understood, guys? Decision tree and random forest are same, but in random forest, the data set is divided into different subsections. To each subsection, a decision tree is applied. So the answer from all the three decision trees are again converted as a mean, and the answer is considered as the mean of it.